All right, we are now broadcasting our geology group activity. So we are supposed to come up with experiments that we would like to conduct on the plate tectonic theory. So yeah, I'm Kayla Dunnigan, and these are Jillian and Lena, correct?
Yeah.
All right.
Yes.
Perfect. So what ideas have you guys kind of come up with or thought about for the experiments?
Well, I was just kind of looking around and Googling what kind of experiments have happened and what scientists have done to prove the theory of tectonic plates, as well as like videos on just like how like elementary school kids and like simple experiments that they've done, and to prove the tectonics or different things on how to teach kids about them. I don't know. So like experiments, there was one that they did where it was just things from around the house. So they had one of those paint trays that you can put like paint in, then you use like the roller to get paint on your roller, and then you can paint the walls. So they had one of those trays. Does that make sense?
Uh-huh.
What that is?
Yeah, I understand what you're talking about.
Okay. And then they had a ruler, a small cup, like a styrofoam cup that they put a hole in the bottom.
Okay.
They put, and then they had a bunch of dirt that they put in the paint pan, just dry dirt, and a water bottle filled with water. And it was kind of going off because the paint tray is, it's like angled because it's not flat, it's kind of angled, and which kind of represents how when the plates hit against each other, the earth rises up. And it was kind of to show the erosion that can happen because of plate tectonics, and because when like the plates hit each other, the earth rises up and creates mountains or valleys and things like that. And the higher it is, the higher it goes up, the rate of erosion increases. So to show that how erosion goes down when water hits it. So they put the paint tray, and I can even show you guys the video I found on YouTube with it. So if we have to end up doing this, I don't know. But they had the paint tray and they put the dirt in it at the very top of it. So there's kind of like an empty spot on the bottom part of the paint tray. And then they put the ruler over the dirt and the cup over on the ruler, and then started pouring water into the cup, which just showed how the water, which was like hitting the top of the mountain, would start to fall, would start to drain down and create rivers down the mountain and into the lake that was at the bottom, or the empty spot in the tray. And then as they poured more water, the dirt just started to move and to fall and like to landslide pretty much. And so that was just showing how because of plate tectonics, the rate of erosion increases. Where water keeps hitting mountains or hills and things like that, it will increase. It will show how avalanches and.
Okay, that sounds pretty cool, actually.
It's pretty simple.
Yeah, and I just think it's very interesting because you can also do other things. We could maybe come up with some other ideas of how to show how the plates hit each other too, and how one kind of goes on top, and what causes the earth to actually move the continents, and and why that's changing. And a lot of it has to do with erosion, like it said in the book. There was the whole idea of the mountains being split apart, right? Those mountain belts that are on opposite sides, right? And they match up perfectly. So that's an interesting concept, how they formed together and then ended up splitting from the plates. Lena, did you have any ideas for?
So I don't know if this is actually an experiment, but it says that we have unlimited time and money. It'd be really cool if you had a satellite that just watched one part of Earth, or multiple satellites that watch the Earth 1,000 years, and speed it all up so that you could actually see what was happening and watch the continents moving.
Yeah, like an overall view.
Yeah.
Like a time lapse of the Earth's movement.
Yeah.
That would be cool.
Yeah, that would actually be really awesome. It would show a lot. Yeah, I was thinking something of that nature. I didn't think about a satellite for it, but that's actually a great idea. I was thinking about tracking like the different earthquakes that happen and actually looking at the movement and the effects that it could have on a certain area, you know? And so you'd see how some of these faults and things like that are going to move more of the land in one direction. And so it would be kind of something that you'd have to do over time, right? So it's the same idea as your time lapse with the satellite. And another interesting thing is also maybe doing more ocean exploration, because a lot of the plates are going to be seen under the water. So I think that would be valuable, exploring kind of what is down there and where all of the plates are meeting, and trying to see the movement and looking at underwater volcanoes and the different islands that are formed from volcanoes and how that affects them and the continents themselves. So those are just some of the things I was kind of looking at.
Especially if you could watch the trenches and see those change.
Mm-hmm.
There is a way to put a camera on it that just kept watching it the whole time, like just watching a fault, and then when an earthquake happened, we actually see what the earthquake is doing and why it happened.
Yeah.
I don't know if there's a way to like see the plates actually rub against each other, and then start to see the lava and everything.
Yeah, the different formations that happen with it. Yeah, I don't know. I'm trying to think of some other ideas maybe that are just kind of out there. It would also be interesting to maybe like plant some kind of a device on one of the plates and see how much it actually moves, and if it is moving, you know, with
cool.
a time like, but you'd have to create something that could actually last in those circumstances and within the heat and certain things too. So like you would have to be able to experiment with materials.
If we had unlimited time and money, I'm sure we could figure something out.
Yeah, right? But yeah, just tracking their actual movement if they are moving, because I mean, that would be a great sign to understand more. I feel like that it is the plate tectonics that are shifting everything. So
I think another thing that was really cool from the reading was how they talked about the different plants and animals and the fossils. So I don't know if there's still experiments that can be done with that, or if people have kind of looked at that already and that section is exhausted. But I think it'd be really cool to look at fossils of plants and animals.
Yeah, that would actually be, it would just further the evidence that's already given too. I think it would just sustain that a little bit more, so that way it's a little more concrete, which isn't a bad idea. I mean, if you can find even more examples, that would be pretty cool. I also think that looking for fossils would be fun. Another idea would be to look more into the different types of rock too as well. Like if they match up, because certain areas have different kinds of rocks and sediment. And so it would be interesting to kind of understand that more a little bit too. Like you're talking about the erosion and that whole idea, that would tell a lot. And if their erosion kind of has the same timeline, if the rocks in these mountains have the same timeline built on opposite ends or on the different continents, then that would actually kind of tell you a little bit more about if they were together or not, I think, you know? Does that make sense?
Yeah.
Mm-hmm. Going on that, you could kind of, like, since the plates are so big and they hit other plates all over the place, types of experiments on, like, the northern part of, say, like, the Pacific plate, and check the age of those rocks compared to like the age of like them on the eastern side. It says see if the whole plate is moving at once. If it's going to create like new, if it's going to be the faults are creating new rock up in the north, where they're creating them on the east side of the plates. So then we can see, that'd be an experiment to prove that the plates have the outline that scientists already say that they have, but that would be a way to like prove that the northern part has these rocks are these old, and the eastern part are these old, and the southern part are these old. And if they're the same age or similar age, it could be they moved at similar points of time.
Yeah, I like that idea a lot. The age-wise comparing, that's, really, I think, valuable. Because there are certain areas that are newer than other areas too, I feel like. And if the ages are matching up, that would give a good amount of evidence for that. Let's see. I think another thing that would be interesting to kind of study a little bit more would be to understand more about the lithosphere and the asthenosphere. Because the text talks about how you have the lithosphere is rigid and what happens to it as the plates are moving and whatnot. And so I think it would be valuable also to put more research into those and understand exactly what's causing all of that to happen and how to make that come to help us understand what the plates are actually doing and how that's being driven.
I love the idea that as the plates slip underneath each other, that it melts and then rises back to the surface. If there was a way to be able to see that, that would be amazing to watch.
Yeah.
It would take a long time because I don't think the rocks are going to melt that fast, but it would be amazing.
Yeah. Yeah.
I think it'd be interesting even to go with, like I was reading about how through the seismic machines, just to see the seismic movement, to like actually go around with seismologists and to look at the fluctuations of when the plates are moving and actually be able to trace, because they've been able to trace all the activity of earthquakes and have like there's like the Californian coast and all over the world of where they've activity. I think at least it's already been done, but it'd be really interesting to be there when it happens and to be able to be part of a team that tracks it.
Yeah, well, and I think that's an important thing too is getting all of that information on tracking it is going to tell us which plates are moving and which ones aren't, So I think that would also be helpful too a little bit to understand a little bit more about which directions they're going in, what areas are being more affected too, which will give more information on those plates there and what's happening. And coming from California and experiencing earthquakes all the time, I think that it's helpful to also know to help everyone around us to understand more and be prepared for that. Because I know that when they study earthquakes and things like that, they also are able to forewarn like that an earthquake is going to happen. They can kind of guess and understand that one is coming, whether it's going to be small or big. They can't tell you exactly when, but they can give you an estimate of what's going to happen. And so they try and watch for them because they can see signs of it as they're monitoring all of these areas. Yeah.
I wonder if as they monitor this, there's differences in how the seismic graphs look if both plates are moving together or if one moves into the other.
Well, and I think some of it has to do with like that one is kind of on top and they get stuck. And so it's a vibration of it kind of coming out of that moment where it's stuck. Does that make sense?
Yeah, that does.
I'm not exactly sure if that's exactly how it happens, but from what I've been reading, it kind of sounds like they kind of get a friction and they're stuck, and then when they finally get out, it sends these waves that cause the earthquakes. Yeah. So, does anyone else have any other ideas or?
I don't know, that's kind of what I had come up with. I'm not sure.
Yeah, it's kind of hard to understand exactly how to research this, especially because I'm no geologist, that's for sure. I think rocks are interesting, but that's about it. But yeah, I'm like, I don't know what kind of resources would be needed to even go into major depth to like see and come up with a concrete evidence that the plates are moving, other than what we've been reading about the fossils and about the different climate, the ancient climate temperatures and things like that. So, like,
Yeah, I don't know the science behind it.
Yeah. Lena, did you have something you were wanting to say?
I was just saying that's where I get stuck also is I've never thought about this before, and so all these things they talk about sound great, but having to come up with new experiments, they're telling me things I've never thought of, so I don't know how to think of something new.
Yeah. Yeah, well, I think we came up with some interesting ideas, you know, the satellite watching it move and actually doing a time lapse of the Earth and focusing really on the continents more so, and also watching some of the trenches and kind of monitoring their movement would be a great opportunity, keeping record of that. And then there were a few others that we had talked about. And I think it'd be interesting just to see if we could come up with more materials and machines that could actually withstand the temperatures and the pressure that would come from being in those areas of the trenches. Yeah. Was there anything else that you guys kind of found interesting in your reading from this week that maybe stood out?
About like experiments on tectonic plates?
Well, about the plates themselves that could maybe help come up with ideas. I don't know. As I'm looking at the book right here, it kind of has some of like the major lithospheric plates and kind of outlines those for us and where they kind of line up. It's interesting because as I'm looking at it, some of the majority of these plates are kind of, they followed the shapes of the areas, you know, of the continents that are drifting apart. So I find that kind of interesting that they, like if you look at the one in between South America and Africa, it kind of follows that shape of Africa and South America and how they would be joined together.
Yeah, I could definitely see how the theory came about that we of Pangea. I mean, it's not the lines aren't perfect, but you could definitely look at the continents and see how they could have possibly fit together at one point and how they separated. And like I said, a lot of the fault lines are around the edges of continents. So that could be why the lines are different, is because they keep changing as the faults keep hitting each other and more earthquakes and volcanoes and stuff like that comes, and it erodes the edges of the continent and moves. That is like the ocean spreading, the seafloor spreading happens. You could kind of, I guess, I'm sure these probably have already been done. We've read about some of them, but a couple of experiments that could be doing is to track to see, like we talked about how the continent isn't just what we can see from the satellite, like the continent continues underneath the ocean. And to kind of, if we had a way of tracking, actually like outlining what the ground looks like underneath the ocean as it goes lower and lower and goes down to the sea, like the bottom of the sea floor, to see if those outlines are even similar to the outlines of underneath the water. Because like an outline that we can't see from a satellite, but is underneath the water.
Yeah, and I feel like those will show more movement too a little bit as the ocean strutting is happening. You know, the seafloor is moving out, and I think it's like, I like your point about that. That would actually be really nice to actually see exactly where the lines are and have that all mapped out, and look at that, because it'll give you better results too.
I thought it was fascinating how the crust underneath the ocean and the crust underneath the earth are. It's a lot of sense. I'm a structural engineering major. The continents and the ocean are obviously different. They're going to have different types of foundations from that type of a perspective, but it's not something I really thought about. And so for me, it was really interesting to see how they meet and read about some of those differences there.
Yeah. Well, it's true, and it's kind of interesting. I came up and I'm looking at, like, they were talking about ocean rifting as well as continental rifting, and both of them are a little bit different. You know, you end up with different results on it, and so I think that's kind of interesting. They have like a diagram drawn in the book, and it kind of shows how it creates volcanoes and geysers as there's rifting in the continental rift, and then as well as like in the ocean, how it kind of makes that ocean ridge, right? So because of like what you're talking about, what they're built of and the different substances, it causes different formations to happen and different results. So that would be something to pay attention to and look at, and kind of watch where those are happening and how they're happening, and the constant effects that they could be resulting from that.
I didn't really have any other ideas. Do you guys have any other ideas?
I know, I'm trying to think of something that would be out there and cool, and I'm like, I'm not creative in that way. But I think it would just be helpful to kind of map the boundaries and kind of track them in the different ways of movement that we can see above, below, and in general, trying to track both at the same time with the mapping out of where the actual continents end under the water. But yeah. Sounds good. Yeah. Does anyone else have any other ideas before we kind of end?
No.
All right. Well, sounds good. So yeah, these are some of the ideas that we came up with for experimenting plate tectonics.
Thanks for setting it up, Kayla.
Thank you very
No
much.
worries. And yeah, so maybe we can meet next week on like Friday, since the other member needs Fridays. Does that?
Friday works for me. I usually get home by about 5:30, so I could get set up by 6, anytime after 6.
Okay.
The other girl said Fridays. I think she said after 6.
Okay, maybe we. Yeah, maybe we could plan on like 6:30ish, so then we're actually doing it by 7 maybe. So that way everyone's here on time and can have a little bit of leeway if they are getting home from work and stuff.
That'll work
That
for
sounds
me.
good to me.
All right, sounds good. Perfect. Thank you guys.
Thank you.
Thanks. See ya.
Bye.
Bye.
See ya.